Okay, lesson 69, gas law problems. In 57, we learned about the ideal gas law, in which if we've got pressure and volume and temperature in one situation is always equal pressure, volume, and temperature in another situation. What this means is that there's a perfect ratio between them. If the pressure increases here, then the volume has to go down, or temperature increases, temperature has to go down. These things move in correspondence with each other. It makes a perfect ratio. So, today's lesson, we're going to be working with them and just make them a smidgen more complicated. And we're dealing with lots and lots of scientific notation. I'm going to work the scientific notation today the old style way instead of trying this scientific calculator business that we had back in lesson 68. Because I think that we'll end up doing a better job if we just work it by hand. But a few things to remember on scientific notation, and I'm going to step through them, and that is how to reduce them down. One thing before we go further, and that is this ratio of pressure, volume, and temperature that works so nicely for us. In one situation equals the other situation. Another way of saying that is pressure, volume in the first times the temperature in the second one equals the pressure and volume in the second times the temperature in the first. And what we're doing is we're basically cross-multiplying and going multiply this times this equals this times this. If you set your formula up for this right away, it will get you a lot closer to the answer when you need to solve it. And our practice set that we're going to work together says begin by solving the ideal gas law equation for T2. So we're going to solve for T2 over here. And if this equals, then T2 equals, and we just divide both sides by PV1. So T2 equals this. PUT, P2, UT, T1 over P1, V1. We can easily take this formula and say, hey, we need to solve for T2, so we need to move this PV over. And the way we do that is we divide both sides by PV, PV1, PV1, and we'll get out this T2. Here I've already taken this first problem that we have and taken all the information and put it over, so you wouldn't have to watch me do that and get bored. Something that we do need to look for, and that is our formula says that we need to be careful with this, because pressure in the second situation should go here. Volume in the second situation goes here. Temperature in the first situation goes here. So pressure in the second situation, we had to come over here and find the pressure, so we find the final volume. Final pressure is 0.0005 times 10 to the 14th, and that's what I put in here, 0.005 times 10 to the 14th. So I copied the information over carefully, and now we're going to work it together and see if we can get the right answer. Another thing to be careful about is changing these scientific notation into simple scientific notation, simplifying them, moving the decimal point, so we only have a number, any number between 1 and 10, instead of weird decimals like this. So we're going to do that in the next step. Generally, I would do that when I copy the problem from the book over to here, but just so you can watch how to do it in case you forget, I went ahead and copied it here like this. So this very first one, let's change it to actual regular notation like we're used to. We need to move the decimal point over here and make this 5. So we go 5 times 10 to the, and to move the decimal point to here, we go 1, 2, 3, 4, 5 places. So we moved it 5 places, and we made this 5 instead of this little wee tiny number. So 5 places, and we made it bigger. So when we make this number bigger, we need to make this number smaller by the same amount. So this is 5 places bigger, this needs to be 5 places smaller, and that comes out to 10 to the 9th power. So subtract 5 from 14. And times. We're going to move this over between the 1 and the 4 and make it 1.4. So 1.4, and move it over there, we went 1, 2, 3, 4, 5 places again. So we made this one 5 places bigger, we need to make this 5 places smaller, so times 10 to the negative 8 minus 5 is negative 13. And then for this one, we move the decimal point 2 places to make it 3. And since we made it 2 places, this number 2 places smaller, this number needs to be made 2 places larger. So times 10 to the 7th. And then down below here, working this one, we move it 1 place and just make it 5. Since we made it smaller, this number needs to go bigger, so 5 times 10 to the 4th. And here, we're going to move it 3 places and make it 8. Since we made this 3 places smaller, this needs to be, we made this 3 places bigger, this needs to be 3 places smaller, so minus 3 is times 10 to the negative 7th. Okay, and then now we're ready to solve it. One thing to look for right away is if you have any terms that are the same on the top and the bottom, you can just cross them out. We're going to look at each of these as separate. So 8, here we've got a 5, and here we've got a 5. So we can just cross those out. Since those are both the first terms, we've got 5s. We'll let the rest continue there. If this would be a 7 and this would be a 7, both of them positive or both negative, we could cross those out, those 10 to the 7th powers. But we can't, because the one's negative and the other's positive. Now, this equals... That's the cool thing about scientific notation, is it's so easy to do in your head or very simply with a calculator that I wouldn't use the scientific calculator to use it. This is the reason they have scientific notation, is to make it easy to work. So 10 to the 7th power, so we add, when we multiply, we add the exponents. So 7 plus negative 13. Okay, so 7 plus negative 13 is going to be negative 6. Negative 6 plus 9 is going to be positive 3. So times 10 to the 3rd power. And then here we go. 3 times 1.4. I've got a calculator right here. I'm going to work it. 3 times 1.4 equals 4.2. So 4.2 times 10 to the 3rd power. And on the bottom, all we have out in the front is 8 times 10 to the, and we've got negative 7 plus 4 gets us a negative 3. Negative 3. Okay, we're not quite finished. We need to simplify it just a bit further yet. So, now we subtract the exponents. When we're going like this. So 3 minus negative 3. When we subtract a negative, it's the same as adding a positive. So 3 plus 3 is 6, 10 to the 6th power. And then we're going to divide this. 4.2 divided by 8. I'm going to use my calculator again. Divided by 8 equals, and it's 0.525. 0.525 times 10 to the 6th power. Okay, that can be your answer if you like. We could simplify this. I think I would, just because we're using scientific notation and we're doing it correctly. I want to move this decimal point over into this spot and make this 5.25 times 10 to the, and we made this number bigger, so we need to make this number smaller. We're going to make this 10 to the 5th power. And we are done. Another way you could solve it is you could say, hey, let's just totally move this guy and make it correct. So we're going to go 5, 2, we're going to move this decimal point 6 places. 1, 2, 3, 4, 5, 6. So if we add on 3 zeros, 4, 5, 6. That would be our answer as well. All these numbers are saying the same thing, and any of them would be acceptable as answers.